What we will do on this worksheet here is we're going to find the oxidation number of the elements in the chemical formula. And there we go. And we did this in class with the salt rotation, where the formula was given to you and you needed to find the positive ion. It works very, very similar to it, which when you need to find the oxidation number of elements in a formula, first thing you're going to work backwards. I'm just going to kind of summarize backwards. For me, that means I'm going to start with the negative. The negative atom in the formula. Okay, and then I'm going to work backwards. You're always going to know the negative charge, the negative oxidation number. And since I know that, like ionic bonds, the sum of your oxidation numbers will equal 0. Okay, so the formula is neutral, and by knowing that it's neutral and knowing the negative ion, you can find the charge or oxidation number of the positive ion. So you should have your notes at your desk by now. And we'll look at question 1 and 2. Question 1 and 2 have the same elements. Okay. Question number 1, this is how it will be obtained. We want to find the oxidation number of each element. Okay. I'm going to rewrite the formula just because it makes it a little bit easier here. I'm going to work backwards, which means I am going to start with the negative atom, which is always the one on the right. And I know this by either its placement on the periodic table, like sulfur's example here. I know that sulfur from the periodic table is a -2. Okay, if each sulfur has a -2 charge, okay, so each sulfur has a -2 charge, and there's one of them, that is a total of -2. Okay, so now I'm working backwards. I'm going this way. Okay. So I'm going to find out what the charge of chromium is, or the oxidation number of chromium is. Alright, so if there's one sulfur that carries a -2, and I know that this formula is neutral and it equals 0, to have this cancel out, chromium has to be a +2. Because a +2 plus a -2 equals 0. So, the oxidation number for each element, chromium is a +2, and sulfur is a -1, or excuse me, a -2. Now, since chromium is a transition metal, it has different and multiple oxidative states, gives it different properties, but we don't need to know that right now. I'm still going to do the same thing. I'm going to start backwards. I'm going to find out the oxidation number of the negative ion, which again is going to be sulfur in this case. Sulfur, again, is -2. Alright, so if each sulfur carries a -2, and there's 3 of them, that gives me a total of -2 times 3. I have a total charge of -6. Okay. If the overall charge of my negative is -6, and I have 2 chromiums, I've got to find out what times 2 equals 6, and that is 3, so my oxidation number of chromium is plus 3, because 3 times 2 is positive 6, and positive 6 plus minus 6 is 0. So the oxidation number for chromium, in this case, is now a plus 3, while sulfur is a minus 2 still. We'll skip a few of these. Anything that we do not do in the notes, I would like you to practice and then check your answers in the classroom, as far as the Google Classroom, so you can confirm if you're doing them correctly. Alright, so if we look at question 6 is an ionic compound that has a transition metal with a polyatomic. I can see that it's a polyatomic because I see there's parentheses. Sometimes they won't have the parentheses if there's only one, but in this case it sticks out like a sore thumb. Sulfate is a polyatomic, so SO4 has an overall charge, and I know the charge of it because I look at my reference materials and I see sulfate carries a charge or oxidation number of minus 2. So that minus 2 is for all of the SO4. If there's one SO4, okay, and there's only one copper, and I know that these equal 0, the oxidation number of copper has to be plus 2. Plus 2 plus a minus 2 will equal 0 because there's one of each. They must be the same, just opposite charge. So there's my oxidation numbers. Copper is plus 2, and sulfate is minus 2. Alright, if you look at 11, I'm changing 12. 12 on yours, I believe, says CO2, and I would like you to change it to SO2. Now, if you look at 11, there is something that I would like you to notice. Comparing 11 with the previous 3 examples. And this is something that we'll need to see in preparation for the test, is that 11 and 12 are molecular. We can still determine the oxidation number for formulas, whether they are ionic or molecularly bonded. You're going to do the same thing that we did in the previous 3 examples for these molecular bonds. It just may be different for some of these elements because of reasons when we get to number 12. So silicon dioxide would be the name, but we're giving you the formula, so therefore that won't matter. I'm going to start with the negative ion first, and then I'm working backwards. Silicon is an element that does not act ionically, it acts molecularly, FYI. The oxidation number of oxygen is minus 2, and will always be minus 2. If there's 2 oxygens, 2 times the negative 2 oxidation number is an overall charge of minus 4. These will also equal 0. If there is 1 silicon for the 2 oxygen, and we know that these equal 0 in the 1 to 2 ratio, silicon's oxidation number must be positive 4 to cancel out the minus 4 of the oxygen. So the oxidation number for silicon is plus 4, and the oxidation number for oxygen is minus 2. Looking at number 12. Okay. I hope that you see what I would like you to see, and I would like there to be some confusion. Okay. And it means that if you have a little bit of confusion, it's good. Okay. And it's with the oxidation number of sulfur. So, if I follow what I need to follow, I'm going to know the oxidation number of the negative ion, and I know the oxidation of the negative ion, which is oxygen, which is a -2. Oh, I wrote silicon instead of sulfur. Sorry, apologize. Okay, so let's fix that. Alright, so oxygen has a -2. -2 times a 2 is -4. Alright, so if two oxygens each have an oxidation number of -2 for a total of -4. If we looked at example 1 and 2, sulfur was a -2. Yes, it is a -2 in that compound that acts ionically. This is different. This is a molecular bond. So I can't say S is -2. If that was the confusion and you're like, wait a minute, I have two negatives, that was good. But now we got to kind of tweak it just a little bit. So ignore that. If I know that the oxygens, and there's two and each one has a -2 oxidation number for a total of -4, if these equal 0 and there's one sulfur, sulfur has to have an oxidation number of +4. So my answer would be sulfur is a +4. It goes against what we've done on the periodic tables with the ionic molecular and what's been done in class so far. But again, it is a formula, and we're asking you to find the oxidation number, and this formula is molecular. So sulfur is +4, and oxygen remains -2. That's not going to change. Alright, last two. And if you look on the second column, you're going to see zinc and silver. Anytime you just see a single element, we're going to treat them like ions. Okay. And what is the oxidation number of zinc? Zinc is part of the diagonal rule. Zinc always has a known oxidation number of +2. Silver, same way. So if I see a single element, just show us what the oxidation number is according to any of the notes that you've had in previous classes, because that's all you have to go by, is that periodic table and what you have memorized. Silver is +1. So, take a few minutes, finish the rest of these, check the rest of them with the answers that will be in the Google Drive.